In our next example, we're going to be finding f prime of 4, that is the derivative of f evaluated at x equals 4, for f of x equals 2x plus 1 over x minus 1. Now, as was the case in our last problem, first thing that we're going to need to figure out is what is f of 4, because both of our different formulas for the derivative involve an f of 4. So that'll be 2 times 4 plus 1 all over 4 minus 1. Your numerator is 9, your denominator is 3. That reduces down to 3. Now, like we did in the last video, I'm going to set up the expression for both of these derivatives, or rather set up both expressions for a derivative, and then we'll make a decision about which one we want to do. So this could be the limit as x approaches 4 of f of x minus f of 4 all over x minus 4. If we do that, that'll be the limit as x approaches 4 of 2x plus 1 over x minus 1 minus 3 over x minus 4. Certainly a manageable limit to evaluate. The alternative would be the limit as h approaches 0 of f of 4 plus h minus f of 4 all over h. That would be equal to the limit as h approaches 0 of, we'll replace all of the x's with a 4 plus h. So this would be 2 times 4 plus h plus 1 over 4 plus h minus 1 minus f of 4 all over h. Now both of these are going to require a bit more work. Let's talk about that work. On this one, I notice that we have a fraction inside of a fraction. So the very first thing that I'd like to do is multiply top and bottom of the big fraction by something to clear out all of the other fractions. So given that the smaller fraction has a denominator of x minus 1, I'm going to multiply top and bottom by x minus 1. Now this x minus 1 will distribute to both of the terms in the numerator, and I'm not going to bother distributing it in the denominator. We'll leave it factored for the time being. So my new numerator is going to be, when we have 2x plus 1 over x minus 1, and we're multiplying by x minus 1, the x minus 1's will cancel. Then the minus 3 didn't have anything attached to it, so that will continue to just be 3 times x minus 1. Your denominator will be x minus 4 times x minus 1. Now there's a temptation here to say let's cancel out these x minus 1's, but unfortunately because of the pluses and minuses that are in the numerator, that would violate the order of operations. Instead what we'll do is distribute that minus 3 through the numerator and then combine like terms. So distributing the minus 3, the positive x becomes negative 3x, and the minus 1 becomes plus 3. Denominator is still a polynomial. I still want to leave it factored. Combining like terms in the numerator, 2x minus 3x will give us negative x, and plus 1 plus 3 will give us plus 4. Now we are about to see some good things happen. As a common factor in the numerator, I'm going to factor out a negative 1. Factoring out a negative 1 will leave us with a factor of x minus 4. And the reason that that is good is because we now have an x minus 4 in both the numerator and denominator, allowing us to cancel those out. Once those are canceled out, we are free to use the direct substitution property. And in using the direct substitution property, we will get negative 1 over 4 minus 1 for a final answer of negative 1/3. This represents the slope of the tangent line to the given function at x equals 4. Next up, I'd like to do the other definition of the derivative that we had up top here. Once again, we see a fraction inside of our fraction, but I'm going to do a little bit of algebra before we get rid of that fraction inside the fraction. So first I'm going to distribute the 2. We'll get 8 plus 2h plus 1 over, combining like terms, we'll get 3 plus h. That'll be minus 3 all over h. More like terms to combine in the numerator of the numerator. 8 plus 1 will be 9 plus 2h over 3 plus h minus 3 all over h. Once we're at this step, I think now is a good time to get rid of the fraction inside of the fraction and to get my pen stuck in the cage. So we'll multiply top and bottom by 3 plus h. And like we saw back here at this step, this is going to distribute through to both of the terms that are in the numerator. When we distribute it to the first term, the first fraction there, it's simply going to cancel with the denominator that's there. So that'll be 9 plus 2h. Then, distributing to the second term, there's nothing there for it to cancel with, so it'll just stick around. The rest of the algebra is going to look very similar to the first method. We're going to combine some like terms and then see if we can cancel something in the denominator. So applying our distributive property, we'll distribute the negative 3 to get a minus 9 minus 3h. Combining like terms in the numerator, we'll have a 9 minus 9, those cancel, plus 2h minus 3h, we'll get negative h. Oh my gosh, that is good news. Just like we did in the previous form, we can factor out a negative 1 from the top and cancel an h with an h. This will be the limit as h approaches 0 of, numerator will be negative 1, denominator will be 3 plus h. Applying the direct substitution property, we replace all of the h's with a 0, and we are left with negative 1/3. Now to reiterate what I said on the last problem, I'm going to repeat for this problem, you don't have to do both of these. You only need to get comfortable with one or the other. So as long as you're comfortable with either one of these processes, you should be good moving forward.